In my presentation, I would like to just to give you some highlights about an overview of coal ash risk. And when we think and talk about coal ash and the environment, it's very important to see it in a bigger picture of the water energy nexus. This is something that has been attract the attention of many scholars, particularly recently, but for many years, trying to understand the relationship between water availability and the ability to generate power, to generate electricity. And there are many links between water and energy, how much water you need to generate energy, and at the same time, do you have enough electricity to activate water and for pumping, for treatment, and so on. And at Duke University, we particularly focus in our research on the energy-water quality nexus and trying to understand different aspects of how energy exploration, production, generation affects the water quality, and that could be for mining, coal ash disposal that we're going to focus today, shale gas and fracking, and tar sand. And it's always important to see the big picture when we're actually talking about contamination issues and all of that. So that's kind of to give you the background. And within the coal ash, we've been working, myself with Helen Sue Kim from the Pratt Engineering School, and with a long list of PhD students that were involved in trying to understand the different environmental effect of coal ash and how it would affect the environment. Now, why we worry about coal and coal ash? Because coal has been a major source of electricity in this country and many parts of the world. Until a decade ago, coal has been used about 50% of the energy resources for electricity in the United States. And the last decade, it has been reduced because of the rise of unconventional shale gas, but it's still a major source, and it's about 37, 36% in the last couple of years. So it's still a major source of energy. And if you look at the projection of the US Energy Information Administration, this is here to stay. Coal is not going away as much as perhaps we like. If you're looking at the next few, decades to come, coal is going still to constitute a major source of energy in the United States and many parts of the world. And renewable, which we like to have more, is actually based on this prediction, unless something really dramatic would happen, is not going to be a major source. So during the coal combustion, we are generating a large volume of solid residue, which we call coal combustion residues, CCRs, which becoming the largest waste solids in the United States. We're talking about, this is the map of 500 power plants in the United States that generate about 130 million tons of coal ash every year from combustion of coal. So this is the largest industry waste, and so far the disposal of coal ash has been divided by disposal into landfills, into coal ash ponds, which we are one of the focus here, and through beneficial use, mostly through the cement industry. And there's some kind of debate about why, when you call beneficial use, when it's sometimes, is it actually beneficial? So that's kind of another a question. But this is data based on the EPA information, and we see this kind of three major pathways and disposal of coal ash that has been conducted during the last, 50 years of generating coal and coal ash in the United States. Now the environmental risk for coal ash are first spills of coal ash pond, and I will mention that, leaking of leachates that would generate from either from coal ash pond or from landfills, which are never being dry or never being isolated from the underlying aquifers. So generating leachate would cause mobilization of metals from coal ash, and I'm going to show you in a minute. And then those effluent will move into the environment, into the groundwater or surface water. And there's also issues that hasn't been addressed as much, is the potential of formation of airborne particles, because coal ash is a very small, tiny particles, and when it disposes as a dry form, and many people talking about the transformation from disposal of coal ash from coal ash pond into landfill, well, we not really know what's happened downwind from people who are living next to those landfills, and the probability of generating those particular matter in the air, which has all those contaminants that I'm going to talk about in a minute. So this is kind of the risk, and if you talk about human health, potentially people can be exposed to coal ash through consuming drinking water, contaminated drinking water from coal ash, and from inhalation of particulate from different association of dry coal ash. So what makes coal ash so dangerous and why we worry about it? So the way to understand it, we have to go back in time 400 million years when the coal was formed in an ancient swamp. And the coal, during the formation of the coal, many of the trace elements were concentrated in this geological environment, and over time became what we know about coal. There are different types of coal, different type of maturation of coal, but the thing that the common link about coal is the having different metals, arsenic, selenium, boron, strontium, all being accumulated in this mud that turn eventually, after maturation, into coal. And when we take this coal and use it for energy source in the coal plant, we burn it to up to 1,000 degrees Celsius, and many of those elements will volatilize into the furnace. But very quickly, as the temperature moves and decreases, the fly ash, this is a residual tiny particulate that are generated from the combustion, retain many of the volatile element back into the solid. And in this process, all those contaminants that being volatile from the coal are being captured back into the coal ash, being attached to the surface of the coal ash, which is very important. That's what makes it highly mobile and easy to mobilize later on as we see it. And that's becoming enrichment of all those metals into the residue coal, in the coal ash. Once we dispose this fly ash into coal ash pond, many of those contaminants that are attached to the surface are interact with water and leached back into the solution. And if this solution is being discharged into the waterways in North Carolina, we see a complete cycle of contaminants going all the way from the swamp in the past into waterways of today. And that's kind of the issues that we see with the coal ash. Now, there are about 1,000 coal ash ponds through United States, and they're all, as we're going to show you, pose risk to the environment and for the human health. Why we worry about coal ash? Because this is, as we say, the wet dreams of any geochemist working on any material. You name contaminate, you have it. So we have a long list of contaminants that attached and easy mobilized from coal ash. So selenium, chromium, arsenic, lead, radium, the radioactive element, mercury, boron, vanadium, strontium, you name it, they are there. And so that's kind of the dangers. When they are easily leached out, they can easily contaminate water resources. Now, in our team, what we do in our group at Duke, we take advantage of this enrichment and we look at the isotopic fingerprint of those contaminants within the coal ash, and we building what we call kind of a fingerprint that makes coal ash very different in geochemical and isotopic composition than other types of contaminants. And in doing so, for example, we're using boron isotopes we're using the boron isotope composition of the coal ash, which is a very depleted and in some cases different from other source of contamination that together enable us to identify and to delineate the impact of coal ash into the environment. So far, the evidence, and I think that's the real critical issues, we have to separate from theoretical contamination or potential contamination of coal ash relative to the actual evidence for the impact on the environment. And we have kind of a three mechanism that causing the impact of coal ash into the environment. One are the spills. The largest spill happened in Tennessee Valley Authority, TVA, in Kingston, Tennessee, 2008. The Dunn River spill, a smaller scale in Eden, North Carolina in 2014, showing impact, showing effect water contamination. There are water discharging from the outfall, which has been legal so far until now, after water from the coal ash being discharged into the environment, and we're going to talk about it in a minute. And then we're going to show a new evidence for leaking of coal ash pond throughout the southeast of the United States. Basically everywhere there is a coal ash pond, there is evidence for leaking in the place we have been investigating. So all this together gives us evidence, actual evidence for impact of coal ash in the environment. And one of the striking things is that in the US, until now, and EPA just issued a new regulation that Lisa Evans was going to discuss. Until now, it was legal to discharge effluent from coal ash ponds into the environment through the National Pollutant Discharge Elimination System. So the authority knows how much volume of effluent is being discharged, but there's no any limitation of what's in the volume until now. And that has been a major issue because all those places in North Carolina, we investigated and show in 2012 and show a clear evidence of contamination of waterways located downstream from those coal ash ponds. And this is a picture in Hyco Lake when you actually see the effluent moving from the areas of the pond into the environment. And what we found that some of them have enriched element like elevated level of arsenic in and exceeding the drinking water limitation, the MCL of drinking water, which is a 10 parts per billion. We found much higher concentration in some cases. This is going into drinking waterways. I think this is one of the important slide here because when we looking at the chemistry of the effluent, we see enrichment of some of the contaminants in the effluent relative to the natural background water. We see enrichment of lithium, boron, vanadium, arsenic, selenium, molybdenum, thallium. We see a wide range of contaminants. And that's really important message. When you're having contamination of coal ash, you have the full package. And we've seen it in our work. We see a wide spectrum of contaminants. It's very rare, it's impossible to see only one. And perhaps this will come up later at this point. And we also found out that the arsenic, once it's discharged into the environment, we see a very interesting thing that into the most of the water column, the level of arsenic is not high, it's low. But when we go down into the anoxic part of a lake during stratification time, we see enrichment of arsenic in the bottom water. We also see that in the pore water, the water that in the interface between the lake and sediments underlying, the first 10 centimeters of the sediment, there we see a huge enrichment of arsenic in those pore water. And we can see, here's some data that we have from different lakes in North Carolina. They enriched in boron, they enriched in arsenic. We see that the pore water, relative to our reference in Jordan Lake, which has no coal ash input, we see that any of those lakes associated with coal ash pond have enrichment of arsenic in the pore water, showing the legacy of a long-term accumulation of arsenic in the sediment and release into the pore water. So we're talking about a long-term effect, and if we're looking at the arsenic, we see high level of arsenic in the pore water. Most of them are composed of arsenic 3, which is the more toxic form of arsenic that could affect human health. So the real point of here that we have a very strong evidence for leaking of discharging of coal ash pond into the environment. We're going to show in our next presentation evidence for direct leaking of the coal ash pond into the shallow groundwater, and always the billion-dollar question whether we see further migration of contaminants from the coal ash pond into the drinking water well. There is some debate about it, but I think the real case that we can make that we do see evidence for direct contamination of underlying groundwater and surface water just located near the coal ash pond. In conclusion, we see that the formation of coal ash, which is inevitable part of the coal combustion process, generate solid residue with high concentration of metals, toxic elements that are easily attached to the coal ash and easily removed. This enrichment we use it as a tool to delineate the impact and distribution of coal ash into the environment, and we have clear evidence for environmental impact and contamination of surface water and groundwater from spills, from the discharge of the coal ash pond effluent, and from leaks of coal ash pond. And acknowledgement, the different source of funding from North Carolina Water Resource Research Institute, NSF, and Oak Ridge Association of Universities. And if you're interested in those papers that we have published, you can download them from this website. Thank you for your attention. I guess I moderate my question. Please, we have few, we went late, so we'll move 10 minutes. So we have like 3 minutes of question, urgent question. We're going to have a discussion, by the way. We have like in 11:30, we're going to have a discussion and more conversation. But if you have a specific question, you're welcome to do it. When you have a question, please come to the microphone because probably people will not hear you.
Good morning, thank you. I'm Lisa Sorb from NC Policy Watch. I was just wondering, in your latest research about the naturally occurring coal, the contaminants of chromium-6 and how widespread it is, can you talk a little bit about the geographic dispersion of that throughout North Carolina? Are there hotspots? Are there areas that are cleaner than others?
Okay. Surprisingly, I was not thinking someone would ask me this question. As you know, we published yesterday a paper on hexavalent chromium, which is unrelated to coal ash, and therefore it's not part of my talk. It's two separate things. The importance of hexavalent chromium in a nutshell is to know that chromium in water could compose of chromium-3 and chromium-6. Chromium-6, hexavalent chromium, is the toxic form of chromium. And we found level, maybe this to demonstrate that, of up to 22 parts per billion of hexavalent chromium. Our data was compared to the data that generate from Modena or DQ, the state, and have the similar result. The important things of our study, there are several, but the important thing that everywhere we measure total chromium, the level of hexavalent chromium in the same water were identical, almost, with some analytical error, which means that everywhere you have chromium in your water, based on our data and the DQ data, is actually what you're measuring hexavalent chromium. And this was one of the major kind of outcome of this study, that in contrast to the previous assumption that hexavalent chromium is really rare and only related to anthropogenic contamination, it's actually very highly distributed at least in the Piedmont rocks of North Carolina and behind. To answer your question in particular, we found the distribution in pretty widespread in the Piedmont area. We did not see correlation with respect to the location near the coal ash pond. When you plot chromium versus distance to the nearest coal ash pond, we don't see evidence for higher concentration near the coal ash pond. The geochemical fingerprint that I just talked before, when we do see evidence for leaking of the coal ash pond, we do not see the same evidence with those wells with a high level of hexavalent chromium. And we see here we're using strontium isotopes versus strontium-calcium ratios. We see the coal ash and groundwater near the coal ash pond are very separate, very different fingerprint, that if the hexavalent chromium would have derived from the coal ash, we would not see it. And in fact, we're going to see in the next talk that when you see contamination, you actually see all those isotopes playing into it. Same with the boron, we see much, much lower boron concentration as compared to total chromium in the water. And I think that when you're talking about your question about distribution, it's not only North Carolina. Because of the Piedmont geology spread out all the southeast and eastern United States, basically we suggest that the risk for homeowners using groundwater is actually much wider than we previously thought. So I hope that's addressed briefly the issue there. So I think we should move on. We have time for discussion, so half an hour just, so if you have urgent, I hope not that urgent, but if you have questions, we can